the School of Physics. So today we are going to do circular motion within a few minutes. So today's topic is circular motion. Right? Circular motion. Circular motion is a very important topic, and let's begin. So suppose I have a circle and here we have angle theta 1. Say we call this as this position angle theta 1. We call this position as angle theta 2. So the difference theta 2 minus theta 1 is equal to delta theta. Suppose this circular motion, this pendulum, suppose we have this pendulum and we are rotating this bob attached with a string in a circle. It is at angle theta 1 at time t1 and it is at angle theta 2 at time t2. Then the difference in time t2 minus t1 is equal to delta t. So first of all we have angular velocity. What will be the angular velocity? The angular velocity W, we denote it by W, is equal to delta theta upon delta t, and instantaneous angular velocity will be equal to d theta by dt. Similarly, suppose we have omega 1, angular velocity omega 1 at this point, and omega 2, angular velocity omega 2 at this point. So the angular acceleration will be omega 2 minus omega 1 upon t2 minus t1, which is delta omega by delta t, and instantaneous angular acceleration can be written as d omega by dt. Now omega is also a vector, so when we go clockwise using the right hand thumb rule, the omega vector will be somewhere here. So omega vector will be in this direction. This is r vector. Now when we have this bob here, we have a tangential velocity Vt. Now, how do we denote this tangential velocity Vt? For denoting this tangential velocity Vt, we use Vt, V tangential is equal to omega vector cross r vector. We use a cross product. Omega vector cross r vector is equal to Vt, and when the angle is 90 degree, it is equal to Vt is equal to omega r. Now, when we have this Vt, what will be the acceleration at, which is the tangential acceleration? It is very simple. It is d Vt by dt, which is equal to d omega r by dt. Taking r outside, we have r into d omega by dt, which is equal to r alpha. So r alpha is our tangential acceleration. The next thing that we are going to do here is, so we remember the three laws of motion, right? You remember, the three equations of motion. When there was constant acceleration, we had s is equal to u plus at, v square is equal to u square plus 2s. V is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. So we can use the similar things here. So when we had there v is equal to u plus at, right? Here we can have this converts to omega 2 is equal to omega 1 plus alpha t, right? Omega 2 is equal to omega 1 plus alpha t. Then we had s is equal to ut plus half at square. If you remember, s is equal to ut plus half at square. So here we can write it as s is equal to ut plus half at square. So theta is equal to omega 1 into t plus half alpha t square. Now the next equation was v square is equal to u square plus 2as. So v square is equal to u square plus 2as this can be written in the circular motion terms as omega 2 square is equal to omega 1 square plus 2 times of alpha into theta. Simple, very simple, right? Okay, so the next thing that I want to talk about is the centripetal force. Next thing that I want to talk about is the centripetal force. So I'll be discussing, since we are dealing with objective exams, I'll be discussing with the cases that are mostly asked, and I'll be telling you the direct results. That is the smart work. We have to apply the direct results rather than waiting for doing the derivations in the exam, since we have it as an objective exam and only we have approximately 30 seconds to 40 seconds for each question. So we'll be applying the direct results, and that's how we'll get the best marks. So what happens is about the centripetal force. So what is the force? So what is the force that is keeping this body in motion? So there's a force, there's this force called force centripetal, which is mv square by r, where r is the radius, v is the tangential velocity, and since we know v is equal to r omega, if we write m r omega square upon r, we get it as m omega square r. So this is the centripetal force. Now coming to the special cases. Okay, so if we have to make this body go into a complete circle, if we have to make this body go into a complete circle, the minimum velocity at the bottom, and there should be a minimum velocity at the top. So minimum velocity at the bottom should be equal to root under root of 5gl, or say 5gr, and the minimum velocity at the top should be equal to under root of g into r. So you have to remember this. Direct questions will be asked on this. Then have you heard this angle, banking angle? Okay, so I'll tell you what it is. Suppose you are driving a bicycle, or suppose you are taking a turn, right? So what should be the minimum angle so that you don't fall or you don't skid? So there are two cases. One case is when there is friction, and another case is when there is no friction. So I'll tell you the formula for both. So you're going here, you're riding a bicycle. This is the radius r. Bicycle looks like okay, you're riding this bicycle. So what angle can you tilt to? Till what angle can you tilt? Theta, so that you don't fall. So in case of no friction, the banking angle or the angle will be tan theta is equal to v square by rg, where v is your tangential velocity. So tan theta will be equal to v square by rg, and in case of friction, if there is friction present with a friction coefficient mu, then v square by rg is equal to 1 minus mu tan theta upon mu plus tan theta. Simple. V square by rg is equal to mu plus tan theta upon 1 minus of mu tan theta. Right, so this is the formula, this is the correct formula. V square by rg is equal to mu plus tan theta upon 1 minus mu tan theta. Direct questions will be asked on this formula. Now I'll take you to the next thing. So the next special case is called conical pendulum. The next special case is called conical pendulum. This formula is very important. Direct questions come. So let's begin. So what happens in a conical pendulum? Suppose you have tied this string from here, and we are rotating this bob from here to here, right? And this angle is angle theta. what will happen since this is a string? There will be a tension force. There will be a tension force. And suppose we say the radius, this radius is radius r. So calculating this, like this angle is angle theta. So, and the mass of this bob is mass m. The mass of this bob is mass m. So we can write two equations here. One is T cos theta. T cos theta is equal to mg. Another equation can be T sin theta is providing the centripetal force, which is m omega square r. What is usually asked is when we solve both of these equations, we don't have to solve both of these equations in the exam. What we have to do is T is equal to 2 pi under root L cos theta into upon G. Now this is the direct result we have to remember. This is the length L of the string. So directly they ask in the terms of L, and this direct result comes that tension is equal to 2 pi under root L cos theta upon G. So I hope you enjoyed this lecture on circular motion, and do subscribe to my channel for more videos. Thank you so much.